presentation, which is by Ingunn Wehus, again from the Institute of Theoretical Astrophysics in Oslo. Please, Ingunn. This is again looking at the future. All this last session is really going beyond Planck, right, so to speak. So this will be about Cosmoglobe program.
Thank you, Marco. So if you can see my screen now, I'm going to talk about Cosmoglobe, as Marco mentioned. My name is Ingunn Wehus. I'm from University of Oslo. And you have, by now, you have probably seen this picture plot before at the conference. It's showing intensity as a function of frequency, and those vertical bands in the background is the data sets, the channels that's currently going into the BeyondPlanck pipeline. So that is LFI plus one HFI channel, a few WMAP channels, and Haslam. As both Christian and Duncan and others have mentioned, looking at this plot, there is room to add more data and to expand and improve our sky model. So one natural next step is to add the remaining Planck and WMAP channels. That will give us much better CMB estimations and constraints. Of course, also on the low frequency side, we would love to add more data like CHI-PASS, S-PASS, C-BASS, Coyote, whatever is available, in particular to break degeneracies between spinning dust, free, and synchrotron. And similar on the high frequency side, we would also like to add as much data as possible to do more exact modeling of the components at high frequencies that I'll come back to in a moment. All of this, of course, brings us into what we call Cosmoglobe. This is the funding agency tagline. What this actually means is that we want to integrate the very best data from radio to sub-millimeter wavelengths into a single global joint model, where we simultaneously fit instrumental parameters, astrophysical parameters, cosmological parameters, everything jointly as demonstrated by BeyondPlanck. This means, of course, that we can improve CMB science because we get a better foreground model and because we get a better joint modeling of all these parameters. And of course, when we build this Cosmoglobe sky model, it allows us also to optimize and forecast future missions. As already pointed to several times, this is a natural extension of BeyondPlanck, which again is a natural extension building on years of Planck work. So we will use the Commando pipeline presented here and the BeyondPlanck sky model and Planck sky model as a starting point. And we want to add as many data as possible and have as a complete sky model as possible in terms of cosmological and astrophysical components. In order to do this, this of course means that we need help. We need all of you to join in with your data sets and your analysis and your knowledge about your instruments so that we can actually do this. As an example of a few things we want to do in terms of in the future, in terms of astrophysical modeling, we need to add more components at the high frequency side, like CO line emission from transitions in CO molecules. This produces radiation at very fixed frequencies, multiples of 115 gigahertz. And it's easy to model when introducing Planck HFI, for instance. Another component is the cosmic infrared background from redshifted dust from other galaxies. This can, like the galactic dust in our galaxy, be described by a modified black body, but with a lower temperature. And since it comes from a lot of different redshifts, it will have a long tail to high frequencies and will eventually dominate at high frequencies. The signal itself is expected to be statistically isotropic, similar to the CMB. Also, becoming important is zodiacal light emission, which is again dust, but this time from within our own solar system. Again, can be modeled as some sort of modified black body, but with higher temperatures and dominating at high frequencies, and also with a different spatial structure since it's coming from within our solar system, and time varying. And finally, there is the galactic dust modeling itself. In this plot, this has a very large uncertainty, and the dust grains can be of different types and different temperatures. So we need to do a more exact physical modeling so that we can constrain the various physical parameters and better model dust. And this was just some examples in temperature. There is a similar story in polarization. This is the BeyondPlanck channels we are using right now. The very first and obvious thing to do is to add in the remaining Planck and WMAP channels, and then anything else that is available in polarization. So, as I mentioned, we're using the Commander analysis pipeline, and as Duncan just mentioned, there is two ways of adding more new data to this. One is in time domain, which of course is the preferred method because it allows full mitigation of systematic errors, though it is computationally expensive. This is how LFI was treated in BeyondPlanck. The other method is in map domain, which is computationally cheaper, but of course doesn't have full error propagation, and also doesn't allow us to jointly fit instrumental and other parameters to the same extent as when we work in time domain. And this is how, for instance, Haslam was treated in BeyondPlanck. So a few of the data sets that I have probably mentioned we want to add. It's first of all Planck HFI. Will greatly improve with both CMB, thermal dust, free, CO, CIB, SODI, SET, whatever. The plan is to first add them in map space because that's the easiest thing to do, and then gradually we will replace one by one with timelines as we get more experience and as we are able to model the instrumental parameters needed for doing this in time domain. Similarly for WMAP, which is of course will help with, especially on the low frequency side, with disentangling synchrotron free and AME. We hope that CBES will soon be available, will be very valuable at low frequencies, And the same with SBS, that's already available and ready to be used. And finally, Kyoto will of course give us lots of information at frequencies not covered by other experiments. So we hope very much that that will become available soon. On the high frequency end, we have already FIRES from COBE as well as Derby that are already available as maps and possibly also timelines. As well as IRIS and WISE, both at even higher frequencies. Both are publicly available. Going into high sensitivity polarization experiments, we have QUIET available at 43 and 95 gigahertz, so useful for polarized synchrotron. We have SPIDER at 90 and 150 gigahertz already available, useful for both CMB and thermal dust. And then moving on to experiments that aren't necessarily primarily CMB experiments, we for instance has COMAP, which is an example of an intensity mapping experiment that maps redshifted CO. But since it is a spectrometer operating between 26 and 34 gigahertz with a lot of channels, if we point it towards the galaxy, it's also very useful for as a CMB foreground additional input, especially for AME. We also have PACIFY, that's a starlight polarization experiment, mapping millions of the polarization of millions of stars in the Milky Way. And when we combine with distance measurements from Gaia, this means that we will eventually be able to map out the 3D structure of polarized dust in the Milky Way, and eventually maybe hopefully the Milky Way magnetic field. And of course, there is lots of other polarization and other experiments ongoing, and we would love to combine with anything that's available. So this is an open invitation to everyone to talk to us and join us. And as I mentioned, when we have this Cosmoglobe sky model that will keep getting expanded and improved, we also have a great tool for forecasting and optimizing future experiments. As I mentioned, in order to be able to do this, we need to make it a community effort. It is impossible to do alone. One of the reasons this is possible to do at all is, of course, that it can be done very gradually by keep adding one more experiments or one more foreground component and so forth. Of course, what we really need is data access in order to be successful and to both get the best sky model and to analyze individual data sets the best. It's better the more data we have. So this brings me to the Cosmoglobe website that I'll just briefly show you. Didn't that work? Maybe if I go out of the full presentation. Can you still see my screen?
Yes, Ingunn, we do see your screen.
Okay.
What's it bring?
Yeah, I tried to. Okay. So here is the preliminary web page. There will be more here eventually. Right now, as you can see, the latest news is this BeyondPlanck release conference. Scrolling down a bit, there is a few projects ongoing. We hope to add many more. Going to the About button. There is a little bit about what we want to do. We want to do global cosmological analysis in both aspects of the world. So we want to provide community-based supports, forums, mailing lists, tutorials, meetings, schools, conferences, and so forth, bringing people together to work on this. As already mentioned by many people, in order to get involved in the commander analysis, it's useful to work with someone that's already familiar with it. So this web page is hopefully a nice place to start and get in contact. So clicking on the I'll just mention, okay, here is a head roll, right now dominated a lot by local people in Oslo. We hope that many more of you will join us. So at the bottom of each of the page here, there is this place where you can type in your email address and get added to the mailing list we are setting up to collaborate. And also if you click at the contact button, you can get in contact with the coordinators. Okay, let's try to get back to my talk. And related to this, we plan to organize digital meetings in the future. We should have one next year for everyone that's interested in joining here. We also, in addition to just getting practical or scientifically organized, we need to get practically organized and political. So we need to discuss collaboration policies and so forth. If people are bringing data sets into this, and we don't have a clear rule on how to do this, so we need to discuss with anyone that's interested. So if you have input, please join us. And this will, of course, all be announced at the meetings on the Cosmoglobe websites. And eventually, when this pandemic is under control, of course, we hope to have face-to-face meetings as well, which brings me into the Global Component Separation Network, which is a sister project, or so to speak, it's €500,000 that comes from the Norwegian government, with especially for collaboration between some selected countries. It's all for travel, meetings, workshops, schools, etc. It's not for, it cannot be used for science. But all these activities will be announced on the Cosmoglobe websites, and they are open to everybody, no matter which country you're from. But there is this slight caveat that we can only pay for travel from people from these selected countries, unfortunately. This is the founding members of this network. but the network is still growing. We have more members now, and we want more. So please contact us if you're interested. There will, of course, be more information on this too on the Cosmoglobe website. So finally, let me just conclude by these plots that Eirik showed yesterday. This is the poorly measured modes in Planck, and this is the poorly measured modes in WMAP. So analyzing only one of these experiments, you will end up with some unconstrained modes. However, if you do joint analysis, you will be able to constrain all modes, and then this is a very nice illustration of the conclusion here, that we all benefit from working together, both all of the individual experiments and the scientific society as a whole. So please join the revolution. And let me show you my funding slide. Thank you.
Thank you very much, Ingunn.